Kia ora Ben, Tosif and Snehal and anyone watching from 12MCA. I'm going to do this video to go through exercise 7A in the Stats 1 book and a question in there that is quite tricky when you're still getting used to inverse normal problems. So guys, I think you're going to come back to this question in another month or two and see that actually it's really not too bad, but you have to get used to how to use diagrams with normal distributions and how to use the tables. So looking at it quickly, there's one bit in here that is a really easy normal problem, but the first bit is what we call an inverse normal problem. I've changed it a tiny bit for copyright reasons, but it goes along with question 13, right? So we've got nails that are made in a factory and they're normally distributed with a mean of 1 millimeter. So we can straight away, we can draw a picture and those nails are being labeled as D. The mean is at 1. We're told that 10% of them have got diameters greater than 1.04. So we can draw that on here and we can shade in that we've got 0.1 here, and that means that we know that we've got 0.9 here. Okay, and by now you guys know that the way that our tables work is that they work with the lower tail, right? So it's this 0.9 area here that is going to link up to our table. But we're not told the standard deviation, and we have to find it out correct to 3 significant figures. The way that we're going to do that is we're going to use the link up between the standard normal and the real life thing, which is usually called X, but in this case it's called D for diameter. So what I have to do is go over to my table and figure out if I've got 90% of the probability below this value here, then how many standard deviations does that represent? So remember that the normal curve, the standard normal curve, has an average of 0 and it has a standard deviation of 1. And we can think of it as how many standard deviations above or below the mean am I? And so we're going to get this number here, and then we're going to translate that 1.04 back and work backwards to get my standard deviation. So the first way we can do that is if we're looking for 90% here, we can simply go to our big table here, right? So this table here, all of these numbers are the probabilities for the graph, for the lower tail of the graph, right? And so if we go hunting through here, we can do it this way. And actually, sometimes I just do it this way, right? So here we've got very close to 0.9, and here we've got a bit above it. So this number here is coming from a Z value of 1.28 with a tiny, tiny bit added on. So it looks like 1.28, I don't know, 1.2815. Close enough. Right, these are really painful out here, but they're in there. So that's one way to do it, right? And going back now, that means that I can say this number here is 1.2815 or 1.282 standard deviations above. And that means that I can translate 1.04 by using this formula here, right? So that means that I can say 1.04 minus 1 divided by sigma is equal to 1.282. Or, in words, 1.04 is 0.04 above 1, and 0.04 represents 1.282 standard deviations, right? And you'll see very quickly that that's what we're working with here. So rearranging 1.282 sigma is equal to 0.04. So sigma works out to be 0.04 divided by that gives me 0.0312. Okay, so that's actually the hardest part done. And now we've figured that out, right? We've found the standard deviation. It's equal to a very annoying number, which is 0.0312, and that's millimeters. Okay, right. Now, the other way we could do that is to use a table that makes life easier when we know how to use it. And that's the critical value table up above. If we're working with common values, then this is quite useful. So in this case, we're told that we want to have 90% of the probability below here. So all we have to do is look along here. See, it says this, and that's what we want. And there's my number, 1.282. Right, but when I first do this, I actually like to do it by just ploughing my way through the table and finding 0.9 about here. Right, so 1.282 there and 1.282 there. Okay, so hopefully so far so good. The next thing we have to do is an easy problem because now we know the standard deviation. We have to show that around 2.7% of the nails have diameters greater than 1.06 millimeters. So this is again a really straightforward normal question. Here's my diameter, here's 1, here's 1.06, and now I know that mu is 1 and sigma is 0.0312. So we're finding this probability here. Probability that D is greater than 1.06 is equal to the probability that Z is greater than 1.06 minus 1 over 0.0312. And when you chug that through your calculator, you're finding the probability that Z is greater than 1.923. Here's my Z picture. Here's 1.923. And we want to find 1. So the bit I want is this, but I'm going to find it as 1 minus phi of 1.923. And we can go over to my table. 1.923, let's see, 1.92, so 0.9726. And then here I've got plus 2, so it's 0.9728. So 1 minus 0.9728 gives me 0.02, can I do the maths? Probably not. 0.272. Okay, what were we asked to show? Look, we were asked to show that around 2.7% of the nails have blah, blah, blah. So that is equal to 2.7% as required or something like that. Don't need to write that. That's that one done. On to the next two questions. And Ben, I think these are probably the two that you really wanted a hand with. I suspect you got through the first part of that on your own. This is not too bad, but you must draw a picture and you have to be confident with the tables. Remember that we now know the standard deviation. So we're going to draw a picture that shows us number A for which 99% of the nails have diameters that exceed D millimeters. So reading it carefully, that means that we've got to find this number here such that nearly all the nails are bigger than that number. This is going to be a negative number, but the easiest way to figure it out is to find the number at the other end. So this number here is going to chop off 1% in that tail, but it should be pretty easy to find using my Z value, the Z value that chops off 1% in that tail. Whatever that number is, we're going to take the negative of that value. So moving over to here, I want to have not 90%, but 99% below this value here. Right, so I'm looking for 0.99 here. And that means that the probability that Z is less than or equal to 2.326 is what I want. So that's my critical value. I'll just clean up all of this. Critical value is 2.326. Now we have to translate it back to something about nails and diameters. So the probability that Z is greater than negative 2.326 is equal to 0.99. So that's what I'm after there. The last step is to link this back up with D. X minus mu over sigma is equal to negative 2.326. We need to be 2.326 sigmas below the mean. X is equal to negative 2.326 times 0.0312 plus 1, which gives me 0.927 millimeters. And I think it said, now X is actually D in this question, D for diameter. I think it said two significant figures, so it'll be 0.93 millimeters. Right, look back at your starting picture and see if that makes sense. Well, we had a mean of 1 here, and so it definitely makes sense that we've got about 0.93 here. That's that one done. The next one is similar, but we're looking for an area in the middle. So we're trying to find the number for which 99% of the nails have diameters that don't differ from the mean by more than that number. So we're asking for cutoffs here that actually are very far in the tail. So I want to have 99% in the middle. And if I've got a good picture, I can see that I've got 99% in the middle, so I've got 0.5% out here, and I've got 0.5% in this tail here. So I'm going to do the same thing. I'm going to use my Z table, but this time I'm going to look for 0.005 in this tail, which means I'm looking for, the table always gives me this number. I'm going to use the table and get 0.995. We go to our critical values, and that's what we're looking up here. So we have to be 2.576 standard deviations away, right? So if I want to enclose 99% of my probability around the mean, then I need to be, again, 2.576 standard deviations away from the mean. So this is 1. So we've got Z is equal to 2.576 because I found out that that's the number that solves this situation. So Z's equal to that. I bet you guys have stopped watching because I'm going too slowly. We'll see. Now let's translate that. We're not asked for this value and this value. We're asked for the number for which the nails have diameters that don't differ from the mean by more than that amount. So what we're looking at here is what we have to add on. And the number B is going to be 2.576 times 0.0312, which is 0.08. So this end, so that's what I'm being asked for, but you can see that what we could put on the graph is that we could draw on those two limits. So this one would be 1.08 and this one would be 0.92. And that would chop off 0.5% in each tail. 0.5% here and 0.5% here. Okay, that's that question done, I think. Let's have a look. No, that's the one from earlier today. Yep, there we are. So that's finished off. Send me in any more questions. I will have a little bit of time over the weekend. This normal distribution stuff, guys, probably is the hardest thing we're going to do in stats, and I've done it reasonably early on purpose. So just hang in there with it.